Picture this. It's 2 a.m., the network is wobbling, and your fingers can type commands faster than your brain can think. Today's episode is about flipping that habit, moving from what do I type to why does the network behave this way. We're unpacking a learning path built for the CCIE Enterprise Infrastructure mindset.
And it's a mindset shift. Instead of memorizing knobs and dials, you start with purpose. Why a technology exists, then how it works under the hood, and finally what to configure. That sequence, why, how, what, turns a frantic operator into a calm designer who can navigate complexity with intent.
Let's get practical. In SD1, thinking like a designer means more than slapping an application-aware policy on everything. It starts with the business, multiple internet circuits, critical applications, security posture. You map those needs, understand the control plane forming secure overlays, the data plane steering traffic, and only then do you push policy.
Exactly. The same logic carries into routing. When EIGRP, OSPF, and BGP all live in the same enterprise, redistribution isn't a party. It's a carefully managed handoff. You design boundaries, summarize where appropriate, and make sure each domain has a clear role. It's like urban planning. OSPF manages neighborhoods, EIGRP handles local streets with swagger, and BGP negotiates intercity trade routes. Don't let freight trucks cut through cul-de-sacs.
Nice metaphor. In campus switching, the headaches often come from spanning tree surprises or VLAN sprawl. What should people be thinking about there?
Route placement and convergence first. Your spanning tree route isn't a random switch under someone's desk. Tune timers, pick uplink priorities, and leverage link aggregation for resiliency. On VLANs, segment with purpose. Don't create 1,000 tiny islands if 20 well-defined segments maintain security and performance. High availability in the campus is about design discipline more than clever tricks.
Then there's the fabric buzzword. VXLAN and overlays show up everywhere. Why does a campus need a fabric at all?
Scale and mobility. VXLAN gives you larger address spaces and cleaner segmentation. SD access stitches that together using a control plane that tracks who's where. Think of it as a live directory for endpoints. You get policy-based segmentation, consistent onboarding, and the ability to move users or devices without changing the wiring plan. It's simplification at scale, not complexity for complexity's sake.
People often treat multicast like the weird cousin at a reunion. There, but misunderstood. Why is it in the path?
Because real-time distribution matters. Video, IPTV, market data, sensor streams, multicast delivers once and replicates in the network. You learn PIM modes, IGMP nuances, and how to avoid flooding or black holes. It's a great way to sharpen your control plane instincts.
Let's talk automation and operations. If someone is eyeing the CCIE, where do APIs and telemetry fit?
Front and center. Model-driven programmability, think Yang schemas and interfaces like netconf or restconf, lets you treat devices as data endpoints, not just CLI machines. Telemetry streams real-time state so you can observe the network without polling blind spots. A small Python check that validates your intent before deployment is worth more than a heroic rollback at midnight.
The labs in this path claim to be real-world. What does that look like in practice?
Complex topologies with branches, data center edges, campus fabrics, and multiple WAN underlays. You practice failure drills, route migrations, policy conflicts, and upgrades. It's the difference between passively reading and actively rehearsing, like training pilots with turbulence, not just sunny day flights.
Who's the ideal listener here? If someone's CCNA or CCNP, where do they plug in?
If you're comfortable with routing, switching, and fundamentals, this path adds depth and orchestration. It revisits core topics with advanced scenarios, then moves into SD-WAN, SD access, multicast, overlays, and automation. Each course builds on the last, so you're not juggling disconnected ideas, you're connecting them into an enterprise blueprint.
Speaking of sequence, why start with core routing and switching before diving into SD-WAN or SD access?
Because overlays amplify whatever foundation you have. Solid routing and switching make SD-WAN's policy decisions sane, and SD access's segmentation predictable. The path scaffolds skills, so when you reach fabrics and automation, you're designing on bedrock, not sand.
Let's map the course lineup to outcomes. You've got deep dives on SD-WAN, multicast, SD access, advanced routing, and advanced switching. How do these puzzle pieces fit?
SD-WAN sets the stage for policy-driven WAN design. Multicast sharpens control plane thinking. SD Access introduces campus fabric with VXLAN overlays and endpoint identity. Advanced routing refines interdomain strategy, EIGRP, OSPF, BGP, and safe redistribution. Advanced switching anchors campus resiliency, STP tuning, VLAN design, and high availability. Together, they form a cohesive architecture.
And for the lab exam crowd, does this philosophy help under pressure?
Definitely. When a scenario goes sideways, remembering commands helps, but understanding why the protocol behaves a certain way lets you diagnose and fix. The path trains pattern recognition. Symptoms point to control plane, data plane, or policy, and you know where to look first.
There's also a cost to shiny overlays, operational debt. What trade-offs should people expect?
Policy sprawl, misaligned segmentation, and competing intents. The cure is design hygiene, clear boundaries, shared naming conventions, and telemetry that tells you the truth. Automation should enforce intent, not multiply complexity.
Let's land this. If you want to design networks that are scalable and resilient, this learning path doesn't just hand you a toolbox. It teaches you why to pick each tool, how it works, and what to build with it.
And it positions you for the future. Intent-driven operations, richer telemetry, and fabrics that support zero trust without endless ACL gymnastics. Whether you're chasing the CCIE lab or stepping into architect roles, the real win is thinking clearly under complexity. Ready to move from commands to concepts?